There's this invisible battle happening all around us all the time, even inside of you right now. It's a chemical duel. And today we're going to pull back the curtain on the main fighters, acids and bases, and figure out what happens when they finally decide to make peace, which, as you'll see, gives us salts. Okay, so let me start by asking you something. What could your stomach, a car battery, and a lemon possibly have in common? I mean, they seem totally random, right? But believe it or not, they're all linked by the same powerful chemical secret.
And that secret is acids. They're our first contender in this chemical showdown. And they're not just some obscure lab chemical. They're working hard right now, digesting your lunch, and even helping get your car started.
So, what's the deal with acids? What actually makes something an acid? Well, you already know one of their key traits, that sour, tangy taste of a lemon, total acid move. In a lab, we know they can be corrosive, and they have this neat trick of turning blue litmus paper red. But the real secret, the thing that makes an acid, happens on a molecular level. When you pop one in water, it lets go of these tiny little things called hydrogen ions, H+. But hey, you can't have a duel with just one fighter, right? So meet the opposition, bases. Bases are pretty much the polar opposite of acids. Instead of sour, think bitter. And you know that slick, slippery feeling of soak? That's a classic base. They do the opposite litmus test too, turning red paper blue. And their chemical signature move, when they're in water, they release hydroxide ions, OH-. So let's put them head to head. You've got acids, sour and turning litmus red. And then you have bases, bitter, slippery, and turning litmus blue. They really are perfect chemical opposites. Okay, so how do they actually fight? What do they do? Well, acids are famous for one thing in particular. They really know how to pick a fight with metals. And the general formula for the showdown is pretty straightforward. You take an acid, you add a reactive metal, and what do you get? A salt and hydrogen gas. Let's make this real for a second. Imagine dropping a piece of zinc metal into some hydrochloric acid. It would instantly start fizzing and bubbling like crazy. Those bubbles, that's pure hydrogen gas. And the liquid itself is changing, turning into something new. Zinc chloride, which is a type of salt. And get this, if you were to capture that gas and bring a flame near it, you'd hear this cool little pop. That's the classic science test for hydrogen. Now, in any good fight, you need a way to keep score, right? A way to measure who's stronger. In chemistry, our scoreboard is the pH scale. The pH scale is pretty simple. It goes from 0 to 14. If a substance has a pH less than 7, we call it acidic. If it's more than 7, it's basic, sometimes you'll hear it called alkaline, and that number right smack in the middle, 7, that's neutral. Think of pure water, that's your perfect neutral. And here's the key thing to remember. The further you get from that neutral 7, the stronger the substance is. So a really low pH, like 1 or 2, means a super strong acid. A really high pH, like 13 or 14, means a super strong base. It's a huge difference with each step. All right, so we've got our two heavy hitters. But what happens when they finally face off against each other? Well, that's when we get a chemical truce. It's a reaction called neutralization, and it's exactly what it sounds like. The acid and the base basically cancel each other out. All those intense dueling properties, gone. And what's left behind? Two new, much calmer things, a salt and good old water. Now, when we say salt, most of us just think of the stuff on our French fries, but in chemistry, it's a whole family of substances. You've got your normal salts. That's when a strong acid and a strong base perfectly cancel out, giving you a neutral pH. But sometimes the neutralization isn't perfect. A strong acid with a weak base leaves you with an acidic salt. And you can probably guess what a strong base and a weak acid make. A basic salt. There are even double salts, which are these cool, complex things made from two simple salts combined. Salts also have these really interesting personalities when it comes to the air around them. Some salts are hygroscopic. They're like little sponges, just soaking up moisture from the air. That's why your salt shaker gets all clumpy on a humid day. Then you have the deliquescent salts. They suck up so much water, they literally dissolve themselves into a puddle. And on the flip side, you've got efflorescent salts. These guys do the opposite. They push their own water out into the air and turn into a dry powder. Okay, enough with the lab talk. This stuff isn't just in textbooks. This chemical duel is happening all around you. So let's connect the dots and see where you can find acids, bases, and salts in your daily life. Seriously, acids are everywhere. You've got super strong hydrochloric acid in your stomach right now, the vinegar in your salad dressing, the citric acid in your orange juice, both acids.
And yeah, like we said before, that car battery relies on some seriously potent sulfuric acid. Just think about it. Without that carefully controlled chemical reaction happening inside the car battery, most of us wouldn't even be able to get to work in the morning. It's chemistry we totally take for granted.
Okay, what about Team Base? Well, they're just as essential. That drain cleaner that busts through clogs, that's usually a super strong base. Farmers use bases to treat soil that's too acidic. Ever taken an antacid for heartburn? You're using a base to neutralize that stomach acid. Even the washing soda that boosts your laundry detergent is a base.
Yeah, take a look under your kitchen sink. A whole bunch of those powerful cleaners are bases. Why? Because they're fantastic at breaking down grease and oil, which is what a lot of messes are really made of.
And that brings us to the salts, the result of that chemical peace treaty. And man, are they everywhere. Of course, you've got table salt, sodium chloride, but so many fertilizers that help grow our food are also just different kinds of salts, designed to give plants the exact nutrients they need.
So there you have it. This constant duel between acids and bases is happening all around us, creating the world we live in. Now that you know what to look for, the real question is, what other everyday duels are you going to start seeing?